All right, in this video, we're going to go over Chapter 10, Differentiation of Trig Functions from Master Math Mentor Stu Schwartz's AP Calculus AB exam. We probably a good idea to put parentheses around the 2x as well. So again, this is power rule because the inside function being raised to the 1/2 power. Y prime would be just using power rule, sine 2x raised to the negative 1/2. But then we have to multiply by the inside function. Derivative of sine x is cosine 2x. We still have an inside function. We're going to leave it alone, and we're going to multiply it by 2. That's just the chain rule over again. So to clean this up, this 2 and this 2 cancel each other out. We get cosine 2x on top. We get sine 2x to the 1/2 power on bottom. We can rewrite that as the square root. All right, part A, we get a trig function on the outside. We have another trig function on the inside. So this would be trig rule because our outside function is the sine part. So we're going to take derivative of sine first. Derivative of sine is cosine. We're going to leave everything on the inside the same. If we were to put parentheses, they would be around the x squared. And then we multiply by the derivative of the inside. Derivative of cosine is negative sine x squared. And since this isn't just x inside the parentheses, we have to multiply that by the derivative of the inside piece there. Derivative of x squared is 2x. Clean this up a little bit. We get negative 2x times cosine of cosine x squared times sine of x squared. We put parentheses around the x squared if we would like. No need if you don't want to. Number 2, we got sine x times cosine x. That does have some trig functions there, but we are multiplying the two. So this would be product rule. Product rule, it doesn't really matter what order we do it in. F prime g plus g prime f is the way I prefer it. So f prime of x here. Derivative of sine x is cosine x times g, which is cosine x. This would be our f. This would be our g. Plus derivative of g, derivative of cosine, is negative sine times the derivative of, not the derivative, but just times f, which would be sine. So we end up with cosine squared x minus sine squared x. There's probably something we could do to simplify that, but that does not equal 1 because they're both not positive. If they were both negative, we could factor the negative out and then make them both positive, and it would equal 1. We could probably use some other Pythagorean identity to make that look a little bit nicer, but I think it's okay like it is. Number 3 would be product rule again, because we have t, which would be our f. We got cosine, which would be our g. So we're looking at f prime g plus g prime f. Derivative of t is just 1. So we get 1 times cosine t plus derivative of cosine is negative sine of t times t. We can't really multiply the t's together there because this t is the angle of the function. This other t is not. So we end up with cosine t minus t sine t. We normally write the variable in front if it's being multiplied. Number 4, we got sine 4x plus cosine x over 4. I would consider this trig. I don't see any product or quotient rule or anything like that. So we get f prime of x sine of 4x. We're going to take derivative of sine x first. We're going to leave the 4x alone. So it'd be cosine 4x times the derivative of 4x is 4. Plus, we're going to do a derivative of cosine, which would be negative sine. Since the x over 4 is inside the function, we're not going to change it. And then we're going to multiply by the derivative of x over 4, which would be 1/4. We end up with 4 cosine 4x minus, looks like 1/4 sine x over 4. Fairly straightforward there. Number 5, this x squared is inside the function, so this would be a trig property in this case. So y prime, we're going to take the derivative of cosine first. So derivative of cosine is negative sine. So it's going to be negative sine x squared times the derivative of x squared is 2x. We multiply the negative 6 and the 2x together. We get negative 12 sine x squared. Just did some chain rule there. All right, this problem right here is a little bit different than the one we just did. The one we just did, the x was being squared. And in this case, the entire cosine is being squared. So we would look at this as a power rule. We're going to take the derivative of something to the second power. We're going to multiply the 6. We're going to subtract 1. So we get y prime is equal to 12 times cosine x raised to the first power. And then we have to take the derivative of the inside function. Derivative of cosine is negative sine. We can multiply the 12 and the negative together. So we get negative 12. Typically, we write sine x first if we're multiplying two things, but it really doesn't matter. And that would be the derivative for number 6. All righty, number 7, we're looking at tangent square root of x is equal to tangent times x to the 1/2. This would be just a trig rule since the exponent is on the inside, not the outside. So we're going to take the derivative of tangent. If you remember the rule that we wrote down are the little trick, tangent, secant, secant. So going from left to right, derivative of tangent is going to be secant squared. And then whatever's inside the parentheses times the derivative of x to the 1/2. The derivative of x to the 1/2 is 1/2 x to the, we're going to subtract 1. 1/2 minus 1 is negative 1/2. Clean this up a little bit. Erase this so we have some room to write. We get secant squared. We can change this back to square root of x if we want. We can move this 2 to the denominator. The 2 and the 1/2 is in the denominator. This x to the negative 1/2, we can move it to the denominator. It becomes x to the positive 1/2, which is just square root of x there. All right, number 8, we're looking at secant. The only thing being squared here is the x squared. So if we look back, we had tangent, secant, secant. So if we go this way now, derivative of secant would be secant tangent. So y prime would be equal to secant x squared tangent x squared. And we need the x squared in both places because the x squared is the input and the derivative of secant is secant tangent. And then we're going to multiply by the derivative of x squared, which is 2x. So we can clean this up a little bit. That'd be 2x secant x squared tangent x squared. This x squared part right here is kind of confusing. Like, why do we need that twice? But this is literally the derivative, and it does have two input functions there. All right here, only the pi x to the 4th power, only the pi x is being raised to the 4th power. So I would rewrite this as maybe like that. If the whole thing was being raised to the 4th power, we would either have parentheses around all of it, and it would look like this, or they would have written the 4th power in front of the input. But they're not doing that. So they're only raising the pi x to the 4th power. So this would be trig rule. So y prime, derivative of sine is cosine. We're going to leave the inside of that alone, pi x to the 4th power. Now we're going to multiply this by the derivative of pi x to the 4th power, which is now power rule. We're going to drop the 4 down, subtract 1 from that. So we get 4 times pi x raised to the 3rd power, subtract 1 from the exponent. And then if there's anything inside this parentheses other than x, we need to take derivative of that. Pi is just a number, a constant. Pi times x would be a constant multiple, and derivative of pi times x would just be pi. Clean that up a little bit. We can put the 4 and the pi out front. We could also put the pi x to the 3rd out front. times cosine of pi x to the fourth power. We can multiply these pi's together. It's really pi to the third. So pi times pi to the third is pi to the fourth x to the third cosine pi x to the fourth power. We're done with number 9. Number 10, this is 3 times cosecant is being squared. So this would actually be power rule, even though it has trig on the inside. Y prime, we're going to use power rule, multiply the 2 and the 3 together, 6 times cosecant x to the first power. And now we're going to multiply this by the derivative of the inside function, which is cosecant x. Remember, we wrote this down earlier. We wrote down cotangent x, negative cosecant x, and cosecant x. So the derivative of cosecant, if we were to go this way, would be negative cosecant x, cotangent x. So we get 6 cosecant x. Pencil's not writing for some reason. Cosecant x times negative cosecant x, cotangent x. And now if we were to multiply the cosecants together, and we can pull the negative out front, we end up with negative 6 cosecant squared x times cotangent x. Will be our derivative for number 10. Again, this is from Master Math Mentor. There's the website. I've also linked the website for the AP Calculus AB manual in the description. All right, secant to the square root of 5x. This is the same as secant. And in parentheses, we're going to have 5x. I'm going to do double parentheses here, raised to the 1/2 power. So this would be trig rule in this case. So f prime of x be equal to the derivative of secant. Again, I really like this idea to help us remember this. We have tangent, secant, secant. So derivative of secant would be secant x tangent x. But it's going to be everything inside the input. And we're going to have to write that for the secant and the tangent, because we can't have trig functions without an angle. It's just not possible. And then we had to multiply that by the derivative of the inside function, d dx, of this 5x raised to the 1/2 power. And the derivative of 5x raised to the 1/2 power, we're going to have to use chain rule for that. I don't know what just happened. I really wish it would go away. Come on, come on, come on, come on. There we go. All right, so derivative of 5x to the 1/2 power. We're going to use chain rule for that. So we get secant. We get secant 5x to the 1/2 power, tangent 5x to the 1/2 power. And right here, we're looking at 5x to the 1/2. The derivative of that is going to be 5 times 1/2, which is 5 over 2. Nope, we're not multiplying by the 5 over 2 yet, because that's inside. So it's just going to be 1/2. We're leaving the inside alone, 5x to the negative 1/2 power. And now we're going to multiply by the derivative of 5x, which is just 5. So we got to use chain rule multiple times there. We can clean this up a little bit. The 5 goes on top. The 5x to the negative 1/2 can go to the bottom, and the 2 can go to the bottom. So we get 5 secant square root of 5x tangent square root of 5x all over 2 times square root of 5x. Clean this up a little bit. Looks bad. So we get square root of 5x right there for number 11. All right, number 12. Number 12 is a product rule. We have 2 trig functions being multiplied together. We got secant being multiplied by tangent. So we're going to have to do some product rule for number 12. Remember, product rule, doesn't matter what order we do this in, f prime g plus g prime f. We're going to let this be f. We're going to let that be g. So derivative of 4 secant 3x would be 4 secant 3x tangent 3x times derivative of 3x, which would be 3, because 3x is our inside function, times tangent 3x, because g is tangent 3x, plus we're going to take the derivative of tangent 3x, which is secant squared 3x times 3, and then we're going to multiply that by 4 secant 3x. See if we can clean this up a little bit. We can multiply the tangent 3x and the tangent 3x together. We can multiply the 4 and the 3 together, so we get 12 secant 3x tangent squared 3x, plus we can multiply all of these secants together. We got 2 and we got 1 more, so we got 3 total, and 3 times 4 is 12, and we got 3 secant 3x's, 3 factors of that, so secant to the third power. We can factor out a 12 and a secant 3x. So if we factor that out, let's see what this would look like. 12 secant 3x. We're going to be left with this first term. We take the 12, the secant 3x away. We're left with tangent squared 3x. And in the second term, we took the 12 away, and we took 1 factor of the secant away. So we're left with secant squared 3x. All right, there's a variation of the Pythagorean theorem here. I can show you where that comes from. But that variation says that secant squared says that secant squared x is equal to tangent squared x plus 1. And if we were to change secant squared x to tangent squared x plus 1, tangent squared 3x plus 1, we could then add those together, and we would have 2 of those. So we end up with something that looks like 12 secant 3x times 2 tangent squared 3x plus 1. That's about as clean as it can get. Do you have to know that property? I don't know if you have to know that property or not. It always comes in handy knowing that property. So if you don't remember that property, here's a way that we can come up with that. Sine squared plus cosine squared x equals 1. We know that. And we're looking to get secant squared x. So if we divide this by cosine squared x, that will be equal to secant squared x. But if we divide that by cosine squared, we need to divide everything by cosine squared. Sine squared divided by cosine squared is tangent squared, and cosine squared divided by cosine squared is 1. So secant squared x is equal to tangent squared x plus 1. And that's the property that we used, variation of Pythagorean identity, that we used up in the previous problem. We're almost done. We got a few more. You can always skip ahead. You don't have to watch the entire video. If you feel like you got a pretty good grasp on taking derivatives of trig functions, feel free to stop the video and start working on some of your homework problems. This would be cosine x squared, the entire thing raised to the 1/2 power. So this would actually be power rule. We're going to multiply the 1/2 in front. So we get 1/2. We're going to leave the inside completely alone. Not going to do anything to that. We're going to subtract 1 from the exponent. That'd be negative 1/2. We're going to multiply this by the derivative of this cosine x squared piece, which would be negative sine x squared. And since this x squared is not just x, we also need to take the derivative of that. Then we get 2x. We can cancel the 2's out. So we get negative sine, or negative x. We multiply the x and the negative sine x together. So we get negative x sine x squared on top. We can move the cosine x squared to the negative 1/2 to the denominator, cosine x squared to the positive 1/2, and we can just rewrite that as the radical. And there's number 13. Number 14 is going to use quotient rule, because we do have a quotient, and there's not much we can do to change that. We could possibly rearrange it to make it power rule, product rule, I guess. But probably just a good idea to just go ahead and do quotient rule. We got low D high minus high D low all over low squared. So y prime, the low is cosine x. Derivative of 1 is 0. Derivative of sine x is cosine x minus 1 plus sine x times the derivative, come on, 1 plus sine x times the derivative of cosine x is negative sine x. And we're multiplying there. All over cosine squared. We get cosine times 0 is just 0. We get cosine times cosine, which is cosine squared x. We get negative 1. Actually, we can distribute this negative to that negative, and we get sine times 1, which is sine x. And we get sine times sine, which is sine squared x. Sine squared x all over cosine squared x. All right, at this point, cosine squared plus sine squared is equal to 1. So we get 1 over 1 plus sine x over cosine squared x. We could probably leave it like that. I'm trying to think. We could break this apart. This would be 1 over cosine squared x plus sine x over cosine squared x. Anytime we have a single term in the denominator, we can do this, break these fractions apart into 2 separate fractions. This first fraction, 1 over cosine squared, is in fact secant squared. And then sine over cosine would be sine x over cosine x times 1 over cosine x. So we get secant squared x. We're talking like 5-star answer here. Sine over cosine is tangent, and 1 over cosine is secant. We could factor a secant x out if we wanted to. If this were a free response, I definitely wouldn't still be going this far. We get secant x plus tangent x. But that answer, that last answer there, looks a little bit better than the others. We consider that our 5-star answer. 1516 asks us to find the equation of the tangent line. In order to find the equation of the tangent line, we're going to need to find f prime of pi over 8. That's going to give us the slope of the tangent line. Once we find that, we would plug in pi over 8 into this equation to figure that out. So let's go ahead and do that. I'll probably do 15. I'm probably going to skip 16 because 16 is a very similar problem. All right, so the first thing we need to find is f prime of x. This is really -2, all that raised to the second power. So this would be a power rule. So we get 2 times all this stuff inside the parentheses, tangent of 2x raised to the first power. I messed up. Let me start over. All right, for 15, we're finding the equation of the tangent line. So this would look like -2 times tangent 2x, and that raised to the second power. So first thing we need to find is the slope of the tangent line. We find that by taking the derivative and plugging in pi over 8 into the derivative. We're going to do the power rule first. Power rule first because we got something being raised to a power. So -2 times 2 is -4. We're going to leave the inside completely alone. And that's going to be to the first power. Times derivative of tangent is secant squared 2x times the derivative of 2x is just 2. We can go ahead and plug in pi over 8 if you want. We can clean this up a little bit. I'm going to multiply the -4 and the 2 together. I get -8 tangent 2x times secant squared 2x. We plug in pi over 8 to find the derivative at pi over 8. We get -8 times tangent of 2 times pi over 8 is pi over 4. 2 times pi over 8 is pi over 4. And then secant squared of pi over 4. If you remember your values from the unit circle, tangent of pi over 4 is 1. And secant of pi over 4. Secant is the reciprocal of cosine. So cosine of pi over 4 would be √2 over 2. So secant would be the reciprocal of that, which would be 2 over √2, which we can rationalize the denominator, multiplying top and bottom by √2. We get 2 √2 over 2. Well, the 2's cancel out. So we end up with √2 quantity squared. So we get -8 times root 2 squared. Root 2 squared is just 2. So we get the slope of our tangent line is -16. I'm going to erase this so I have a little bit more room to work out some stuff. So we know the slope of the tangent line is -16. We know this is our x value, pi/8. We need to find our y value. So we need to know what f of pi/8 is. F of pi/8 would be -2 times tangent squared. 2 times pi/8, we talked about that earlier, is pi/4. Tangent of pi/4 is 1. So this is -2 times 1 squared, which is -2. So our y value is -2. So we're going to plug this in. Y minus y1 is -2. That ends up being +2 equals the slope we found was -16 times x minus x1 is pi/8. And I would probably just leave it like that. We could distribute the -16. We can move the 2 to the other side. But I think that right there will get it done for us. Number 16, you do in a similar fashion. You probably had to use quotient rule, but same idea. You use quotient rule to find the derivative. You plug pi/2 in to get the slope of the tangent line. You plug pi/2 into the original function to get the y value. And then you could find the slope of the tangent line. All right, for 1718, it says find the 20th derivative for the following. So we just need to find a pattern here. We can find that pattern by taking a couple derivatives. So f prime of x, derivative of sine is cosine 2x times 2. So that's 2 cosine 2x. And then the second derivative, we're going to take derivative of cosine, which is negative sine. So we get -2 sine 2x times 2, which is -4 sine 2x. We take the third derivative, 1, 2, 3. Derivative of sine is cosine, so we get -4 times cosine 2x. And then we have to multiply that by the derivative of 2x, which is 2. So we get -8 cosine 2x. We take the fourth derivative. We normally don't write 4 primes, we just put a 4 up there. Derivative of cosine is negative sine. So we get -8 times negative sine 2x times 2, which will give us negative times negative is a positive. 8 times 2 is 16 sine 2x. And we see we are back to the original that we started with, a different power, 2 to the 4th power. Make that note, 2 to the 4th power would be that. So let's see where 20 would fall. So f of 20, the 20th derivative of x would be 2 to the 20th power. And where would 20 fall in our pattern? 20 is a multiple of 4. So I think we would fall right there, a multiple of 4. If it was 21, we would be up here. 22 would be right here. 23 would be right here. And 24 would fall in the pattern right there, because 20 is a multiple of 4. We don't need to multiply 2 to the 20th power out. 18, we can do in a similar fashion. It's just going to be product rule here. But I think we could look through it the same way. We're looking at f prime g plus g prime f. I'll leave it up to you guys to figure that one out. A little more challenging than the first one, but there will definitely be a pattern that that shows up, and you guys would be able to work that one out. Your homework now, I do believe that you could complete all your homework for chapter 10. I would just do as many of those as you can. The more we do, the more familiar we're going to be with them. There's only 21 to begin with. If you have any questions about them, again, you can send me an email or send me a message on Remind, and I'll get back with you as soon as I can. I'm not really sure when that will be, but I'll try to get back to you within a few hours.